Hello everyone. So in the previous video you have learned about the galvanic cell. Here we are going to learn the second type of electrochemical cell known as electrolysis. You got to know that electrolysis is opposite to the galvanic cell, meaning the mechanism of how it works is actually different. One of the major difference is in terms of redox reaction. In the galvanic cell, redox reactions happens spontaneously. It happens on its own. But in electrolysis, it's a different story. In electrolysis, yes, although it involves redox, but it is non-spontaneous. Therefore, electrolysis employs the usage of electricity to drive non-spontaneous redox reaction to take place. This picture shows you how electrolysis looks like. Please ignore the word water here. Okay, just ignore it. This solution here should be electrolyte. There are many types of electrolytes that can be used. So, but anyhow, they still have two electrodes. Okay. Take note of the absence of salt bridge here. Okay, there's no salt bridge. There are two electrodes. Most of the time, they are inert electrodes. And what is connecting between the electrodes is also a metal wire, but this time round there is an additional substance here, that is the power supply. And the power supply will actually supply electrons, so electrons flow towards the cathode electrode. Therefore, the cathode electrode will have reduction taking place here. Since reduction takes place in the cathode, well, obviously then oxidation takes place at the anode. In the galvanic cell, reduction also takes place in the cathode, oxidation also takes place in the anode. So this is the same. But what is different is the charge, because electrons are flowing towards this direction. Therefore, here it's a negative charge, whereas the anode will be given a positive charge. So this is different. Sorry, I'm going to write that again. Positive charge. So this is the thing that is actually different between an electrolysis and a galvanic cell. We will be looking at the actual example now. Given this picture of electrolysis and the electrolyte being copper 2 chloride solution, this is an aqueous solution. So in order to determine the oxidation and reduction that takes place, we shall firstly list down all the possible ions that are found in this electrolyte. Well, obviously we have copper, we have chloride, but because this is an aqueous solution, please do not forget that you also contain water in this electrolyte. So what happens is you have your anode and then you also have your cathode. Okay, so you can see copper metal deposited here. That means copper has received electrons coming from this power supply, and it was reduced. Whereas on the anode, you see chlorine gas being released. So we also know that chloride ion has, been attracted. What happens is chloride ion now becomes chlorine gas. Sorry. Okay, but there is also one challenge here, that is, do not assume that it's always the metal ion or the anion that accompanies the metal to be oxidized or reduced, because occasionally water could also be the preferred compound to be oxidized or reduced. So in this case, you will have to be able to predict which compound will be oxidized or which compound which will be reduced. In order to predict which compound will be reduced in an electrolysis, again, we shall refer to this metal reactivity series. Again, like I said, you don't have to memorize them. It will be provided in the final exam. So this series shows you, as the arrow goes down, it shows that the compound becomes easily reduced. Okay, potassium is the one that is hardest to be reduced, whereas if you move down, iron, copper, zinc will be the ones that is reduced easily. So water has a position between aluminium and zinc. So just take note that if you are given a compound, a mixture of water and iron, for example, iron will be the one that will be reduced instead of water. But if you are given another combination, let's say for example you are given magnesium and water, what happens is magnesium ion will not be reduced. Instead, water is the one that will be reduced. For the opposite reaction, the one to be oxidized, there is also different preferences. Now, if you have chloride ion, bromide ion, and iodide ion versus water, these ions are the one that will be oxidized instead of water. But if you have another combination, for example, nitrate and sulfate versus water, then water will be the one to be oxidized instead. In the event if water is the preferred substance to be oxidized or reduced, here I've shown you two different equations of the reduction of water and also the oxidation of water. So when it comes to reduction of water, you can see that initially your hydrogen is positively charged, +1, and after being reduced to hydrogen gas, it becomes an oxidation state of 0. So it's +1 to 0, therefore reduction. For oxidation, you can see that oxygen here initially have oxidation state of 2-, but after it's being oxidized, it has an oxidation state of 0 now. So oxidation. Here, unfortunately, you got no choice, but you got to remember these two specific equations if water was the preferred substance to be oxidized or reduced. We all have learned that the galvanic cell's purpose is to generate electricity. So it's very, very commonly used as batteries or like setups in factories to generate electricity. So what about electrolysis then? What does it do actually? It does not generate electricity. But do you notice something that could actually be produced during the electrolysis? If the substance to be reduced is a metal ion, then at the end of electrolysis we actually get pure metals. Therefore, one of the very, very common purpose of electrolysis is to produce pure metals from solution. We will actually get solid deposits of metals out of the aqueous solution. We could also refine them, or we can have electroplating. What it means is the coating of something with metal as a surface. Okay, so I have a question here showing you an electrolysis with calcium chloride aqueous solution being the electrolyte. Now, would you be able to identify for me the substance that will be oxidized and reduced? I'm giving you about 30 seconds. Just to help you, I will be listing down all the ions available. And water. I hope you got it right. So the one happening at the anode was oxidation, and here chloride ion is the one that will be oxidized. However, at the cathode, instead of calcium, water will be the one to be reduced instead. Because if you remember from the reactivity series, calcium is actually on top of water. Therefore, water is the preferred one to be reduced. It gets reduced easily if you were to compare to calcium. So then it defeats my purpose already to want to produce a pure calcium. So do you have any idea what we should do about this? So how do you think we can produce pure calcium here? The answer is quite simple here. That is, instead of using a calcium chloride aqueous solution as your electrolyte, here we use molten calcium chloride. Meaning the electrolyte contains of pure calcium ions and chloride ions only. So in this case, at the cathode, you got no choice but to reduce calcium. At the at the anode, it is still chloride ion. But now, at the cathode, due to the absence of water, there is no choice but to reduce calcium ions. So this is how we obtain pure calcium. In fact, a few of the metals above water are produced in this way.